Okay, Assalamualaikum and very good day, class. All right. So today I'm going to give you some more description or some assist on how you can work on your mini project. Okay, the first thing I want to emphasize is that for those groups that I ask you to change the group, please, you have to, sorry, for those groups that have to change the title, so you have to come out with new titles and you guys have to email it to me by today. All right, so I'm going to give you some example how you can work on your project. Okay, for an example here, I'll try to create a project where I'll try to build a car control system. Oops, system. All right, so okay, this is the title of my project. Okay, the first thing that I will do is that I will set what is the inputs to my project. So here I'm gonna set what's the input. Okay, so the first input will be uh, gear to move forward, which I will use the switch, and then 2 is the gear which I will use it to reverse the car, and then this one is also I'm going to use switch, and then 3 is the brake which I'm going to use push button here for the brake. Alright, so now I'm done with the inputs. Now I have to describe what are my outputs will be. So this is here my outputs. Okay, so my outputs. The first one is the LED. My first output will be LED. LED 1 will indicate that the car is in gear 1. LED 2 will indicate that the car is in gear 2. LED 3 will indicate that the car is in gear 3. So overall I'm just using 3 gear, and then 4 is the LED. LED 4 that indicates, so LED 4 will indicate that the car is in gear reverse. Okay, this is just for the example class so that you get a brief idea how you can work on your project. Okay, now I have my inputs and I already have my outputs. Okay, what is the next step is you have to describe how your system works. Okay, so here is you have to, okay, if you press on, you turn on switch 1. Okay, let's make this one switch 1, and this one switch 2. Okay, if switch 1 is pressed, oops, is pressed, okay, what going to happen? Oops, okay, what going to happen is that the LED one will light up. Okay, for how long? Let's say we can say for 2 seconds. I mean, right now we don't have to think about the code first, because now we are working on the top level of the project where we set what's the input, what's the output, and how we want the system to work. Okay, so after LED 1 will light up for 2 seconds. Then LED 2 will light up and LED 1 will light off. LED 1 light off. Okay, so this one LED 2 will light up for, let's say, for 3 seconds. We just make the variation here first, and then uh, LED 3 will light up for, so LED will light up and remain static. So remain light up until something happen. Okay, then okay, light. Okay, LED 3 will light up. Okay, remain light up. Okay, and then LED 2 will light off. Okay, this is just the condition. Okay, so then, okay, what happen if switch 2 is sorry, it's not switch. No, switch is not pressed. Switch is 1 is triggered. Okay, and then, okay, what if switch 2 is triggered? Okay, what happened? Okay, switch 2 is the reverse. Okay, we have to make a condition here. Okay, if switch 2 is triggered when switch 1 is not triggered, then the LED 4 will light up. Okay, this is the first condition. But if switch 2 is triggered when switch 1 is also triggered, then the error error will happen and the LED 4 will blink. Okay, this is the conditions. All right, so we're done with switch 2. And now what we move to what happened if the push button if the push button is push. Okay, now let's say if the push button is push. Okay, so if it is push when the switch 1 is what do you call it, switch 1 is triggered, then the LED 3 will light off and LED 2 will light up for 1 second and then light off, and then LED 1 will light up for 1 second and then light off. Okay, that one if the push button is push. Okay, so the push button here is the one that we will use by using the interrupt. So this is our interrupts function here. So this one is just normal switch, but this one is using the interrupt function. All right, and then you have to make another condition. So class, you have to think what is the overlap condition that will be in your system, so that yours, if I mean like overlap happen, your system will not hang. I mean you program the all possible conditions that your system could take. Okay, when the switch one is triggered, switch 2. If the push button is pushed when switch 2 is triggered, then LED 4 will light off. All right. Okay. Now this is the condition that you have. So you have a better idea how complex is your system will be. So after you finalize the whole thing, when you try to brainstorm with your group members, I mean, what is the possible inputs that you can add so that you can utilize all the inputs that we have on 8085, and also utilize the outputs. But the most important thing that you have to show is the complexity that we have here in the system, because this complexity will be reflected in your code, your coding. Okay class, when after you have all of the condition here, then you start to do the coding. I mean, just do it one by one first class. Okay, first you do for this part first for switch one, and then you start the coding. If the switch one is triggered, okay, what happened? Connect the output to LED. Just use the examples that we have in the lab, and then now move to switch two, and then you start to combine it, and then finally you work on the interrupt, and then you start to combine the whole codes and try to simulate it. All right. Okay, now that is just the briefing for the projects. So what I want you to do today is that the lab instructor, the guy, he cannot come for today class because he has something else to do. So what I want to do, what I want you guys to do is that you have to come out with this kind of details so that I can see how your system works here. The system, what is your input, what is your outputs, and how your system works. You have to list all of the possible conditions and how you want it to react, or how you want to show it and or reflect it on your output. So I have a good idea what is the project that you try to come out with. All right, so I want you to do all this detail and email it to me by today at this email. All right, so this is my email. So I'm expecting email from all of the groups in my class by today. Okay, so that is for the project, and now I just want to give you just a little bit brief on uh, the interrupt. Okay class, so you mean if you want to understand the interrupt better, so you have to do the exercise, the lab 05 here, interrupts. I think you all of you have the soft copy for this lab. All right, so I just want to give you a brief introduction on the interrupt. So this is the example of the code where you can see, I mean, this is a well commented code where actually if you just copy it and paste it on MySim85 and try it, you should try to understand it line by line. Okay. All right. So here, if you can see class, I mean the code here, I mean this one is just to set the stack pointer address, and here is the one where this one is we set the data to control register. So this is how we want to the 8255 to be configured, as what I've explained in the class yesterday. So this is the configuration where you send it to the accumulator, and from the accumulator you will send it to the control register of the 8255 chip, and you set it as, see this one, like port A you set it as output, port C you set it is sorry, you port C you set it as output to, port B output, yeah, everything is output. All right, okay, so this is just the example. All right, and then okay, this is the other thing. I mean, this is the new thing that you have to know, where you set the mask. Okay, now here we are setting the interrupts, which interrupt that we want to enable. So here, for example, I mean, this is the example how you can set the interrupt. The first one, you have to set 0 here, means that the mask setting is enabled, and then you can use which interrupt you want to use. For example, if you want to use M7.5, you set it as 1 here, so M7.5 interrupt is enabled. And also this one M6.5 is disabled because we set 0, and M5.5 is also enabled here. So you just send the configuration bit here, and this is the opcode that you have to use to set the interrupt masking. And then finally EI to enable the interrupt. Alright, as you can see here, this is just a normal code. I mean, it's almost the same like what I've explained in the class yesterday. But the thing that you have to realize, the different here is this one, this part here, the first part is different, because here where it bring the interrupt in, where you have to set the interrupt configuration. And then the next thing is this one, the interrupt service routine. So this is fixed. If you're using 6.5 interrupt, this is the function name that you have to put. I mean ISR 6_5. And then class, okay, these are all the what do you call it, the function that you want to do when you press the interrupt. So if you see the interrupt here, it's being connected. I mean, you can read on the module, where you can see the interrupt here is being connected to the push button. So when the push button is on, is triggered, so the push button goes down and the electric flows here, and then the interrupt will be enabled. When you press the push button, what will happen in the program is that the program will automatically jump and go to the ISR. Okay, these are all the functions. Is custom functions where you can have, uh, or where you can, what do you call it? You can oh, sorry, this is the must. This is a must. This is the one that you just have to follow, because this one is all the steps that you have to do, like store register AF to stack area, because you want to store all of the current value that your program is processing in the stack area, so that when you go back to your current program here, it will not lose any data, because when you press the interrupt, automatically the processor will jump and service the interrupt. So that's why you have to do all of these steps. So all of the steps is necessary, or is compulsory. You have to have this one here, the one in the red color. And then okay, this is the part where you can see it's a custom program, where whatever you want to do here. And then, oh, sorry, okay, no, no, yeah, this one is custom, but the pop here, the pop here is necessary. And okay, all of the code that I highlighted here is necessary, like this one pop D, because whatever you have already, because now the program is going back to the main program. This is just to show you the example how you can use the interrupt. So this one is retrieve back whatever in the stack area, and push it back to the DE register BC. You store back whatever value that you were using before, so that if they go back to the current program that you are processing, they will not lose any data. And then finally you have to put this code here so that you re-enable the interrupt, because this is a mask interrupt. So when the interrupt enables, the software automatically will disable the interrupt. So that's why when you want to end the interrupt service routine, you have to re-enable the interrupt, and then this is the return back to the main program. So when it goes here, and it will return back to the program, and it will check the PC, the program counter, where's the current address of the processor is processing right now, and just execute or continue to do whatever processing that they have to do. Okay, class. So I think that is just the brief idea of how you can use the interrupts. I mean, the better thing to do is that you have to go through the examples so that you get a better understanding. Okay, so I just want to emphasize, class, this is your best opportunity to recall back whatever you have learned in the class, and this is the best opportunity for you to practically practice whatever you have learned, because this will help you a lot for your test, your final exam. Because if you know how to do the coding, I'm sure that you will pass the course, and you will pass the course with a good grade. Okay, and then there's another announcements that I want to tell you. So in week 13 we will have lab tests. So you guys have to be ready. That's why it's important for you guys to involve in the project, try to contribute, try to develop the code together with your friends, because in lab 13 we will have lab tests where we will test your capability on doing the coding, and all of the three lecturers will be involved and evaluate all of the students. All right, class. So I think till here. So I'm expecting to receive from you each groups about the documents regarding the input outputs and the detail of your system, right? Okay, see you next time.